What's going on? Redetach here. Going to be doing another VST plugin development video. This time not going to be going over JUCE, but the Steinberg Media VST SDK. I believe it's a little more low level, not as abstracted as the JUCE is, and it's a little more focused, meaning that with the Steinberg SDK you can only create the VST plugins. With JUCE, not only can you create VST plugins, but also just desktop applications, other things that use user interfaces. Thankfully, though, Steinberg Media, their SDK has this thing called VSTGUI, which allows you to write XML type files to make user interfaces using that SDK. So we're not out of luck there. Thankfully, there is going to be a way for us to just make like a demo user interface. Nothing super involved like JUCE, but I do recall I had a lot of just links in my original VST development video where I explained the difference between Steinberg and JUCE. I'll try to include those links in the description below on this video because they're very helpful, and I'll be using some of those links during this video just so I make sure I'm on the right track. But mainly I'm going to be looking at my GitHub, as I do have some example code on there that will, I'll just be looking over and trying to mimic. Again, that's kind of like the demo project idea I'll be starting with today. It'll just be a fuzz plugin we're going to make, with the Steinberg Media SDK this time. So I already have it downloaded and installed, and I'll be referencing this video from iCloud. They have downloads to everything here that you will need to use the Steinberg SDK. I believe you need CMake for using JUCE as well, but you will need Visual Studio because the project generator creates Visual Studio solutions. So I have it here in my downloads. And the project generator is already built, unlike in JUCE where you have to build the producer project generator when you install it. It's shipped to you as an exe file, which I think is funny. But here it is. I'm going to not change any of this because that's what I wanted. But I'm going to call this plugin Laser, L-A-Z-R. And you have to do this for, I don't really get the bundle ID, but I'm going to call it this. And then once you have all your information in here, there's nothing on this page. When we hit create, it'll launch the solution once it's created. You don't have to open Visual Studio. So there it goes. Now, here's our solution directory. All of our plugin source files are in this LAZR or your plugin name here directory. CIDs, we won't edit that one at all. Version, I don't think, that's more boilerplate, but project information for when it builds. DLL main, we're not going to touch. I don't think we touch the entry C++ file either. We're really worried about controller processor.h and .cpp files. However, we're going to have to make some parameter IDs. Kind of like how in JUCE we had to create an ID that we could relate a slider on the user interface to a value in the backend for the processing. We're going to have to create and explicitly define those parameters in the Steinberg SDK. And we could have done this in a similar way creating JUCE plugins, but I went around it. I just didn't make this additional file. But what we're going to do is we're going to add a header file. And I'm just going to call it rams.h. Should be big enough on the screen, but I'll make it bigger. And what we got to do in here is we're going to make enum. That's just going to be our param IDs. This is a fuzz plugin. And the ID of the fuzz parameter is just going to be 0, first possible value you could choose. So not too much going on there. Then we got to go to the processor header. Down at the bottom here under the protected area, we can pass in this, I'm going to call it ffuzz here. I'm not exactly sure why we call it K in the other one. I'm sure I'll remember as we go on. But that's all we need to add here. Now in the controller C++ file though, so we're going to want to include params, that new header file we just created. And here, as the boilerplate says, this is where we actually pass in our parameters. So just like we add like a slider attachment, this is essentially the same thing for Steinberg Media. Fuzz, null pointer, parameter info, shape, and automates. Matter fuzz ID. Third argument 0 means that parameter changes continuously. Initial value is 0.5. We're already going to the processor C++ file. So include params. So it starts off with the actual process block and comments it out. So I'm actually going to do something like this. Now we're going to put an if statement here. So we're going to do if param q down points -1 sample offsets value was declare it's true. So we're saying we did have a parameter update essentially. We're getting the ID of that parameter. In case that is our fuzz ID, that was the parameter that was updated. Then we define ffuzz in processor.h and then pass it in. So here is where, again, we're actually detecting what parameters were changed in that instance. And then if it is this one, we're going to reset / update our ffuzz if we defined in processor.h private protected. Yeah, and that's just an association to this the ID, which we instantiated over here, like a slider attachment in JUCE. So that's us actually detecting and updating the params as the boilerplate says. And we just had to add this outer if statement around the switch, and then we added our case. Now I can't implement the processing, so let me just go ahead. So this is kind of like taking care of a case where there's no input or output. We're not going to do anything. But it's not bad, it's okay result, okay? So I guess this is how we're just like exiting the processing. We detect the parameter changes, but no audio in, no audio coming out. So we're not, let's just get out of this function, okay, result, okay. But here we actually get number of channels. So there's this thing. Data is this VST process data type. So that's passed into this function call, and it has this input 0, I guess, is the input buffer. I don't know what the other indexes would represent, actually. But here we get another interesting part. So we're doing a double pointer. Data inputs 0. It's all channel buffers 32. And this data thing also has output. So I guess it's like you could technically create a VST plugin that's like a bus, and there's multiple inputs. But you might throw this on a bus, and that way in FL Studio, like there's multiple inputs coming to the bus, so you don't have to worry about changing this value to anything but 0. But we're gonna have the same type of channel buffer, channel buffer 32. So this is our current audio, dry signal, and then we're gonna be writing to this one. There are pointers of pointers because this is an address, so we gotta just get the values at it. Because this is an array, it's probably allocated. So we gotta dereference it a bunch of times. Alright. Now to actually do processing of the audio. So I believe channels is just like stereo left, stereo right. So this is only going to execute twice, but it should just execute once for stereo left, once for stereo right. So here we're getting a pointer to the input sample. And we're getting a pointer to where we're going to write it. And then just have an uninitialized sample that's going to store the temporary data. And we got a nested for loop here. So here we're actually iterating over the number of samples we need to process. So the outer for loop in this instance is for stereo left and stereo right. We need those samples and also a pointer to the input sample, pointer to the output sample. Now for every sample that we need to write, we're going to initialize temp as the value at pn plus the value at pn 20.0 times a fuzz. So again, right above here is where we update a fuzz, and we can use that value again after we update it. And then I'm going to actually do some cleaning because this is a fuzz. So we're doing plus plus at the end because we are, I believe, we'll never exceed right to like unallocated memory or anything, just because we're indexing in from a range of 0 to data num samples minus 1, and that is the length of the input and output buffers that we defined here, captured here. And explain this, we're writing to, dereferencing this pointer, the value at whatever this address is pointing to is equal to a temporary value. And then we're incrementing the pointers, so we're going to the next address so we can process. Yeah, we're never actually using I to index anything. So keep that in mind. And honestly, that looks like it should be it. So maybe I can just Control-Shift-D, and we can build this VST plugin from the Steinberg SDK. Which, if you think about it, is a lot less involved than the JUCE framework. Didn't have to deal with sliders at all. Granted, I don't think there's going to be like any elements on our user interface, but this should still be a usable fuzz plugin. So build, debug VST3. Let me paste it. Now, I don't know how loud this is going to be, so I'm very, very sorry to anyone's ears. May want to turn down their volume right now before I actually load this. Okay. And it looks like it's okay. So I'll just load FL keys into here again. Okay, that works. And there it is. It's a pretty disgusting noise. It works. Now, it's not too bad, but as you can see, like, there's nothing we can do to actually play around with it, which is why there's this thing called the OpenUI editor, which will allow us to actually create the user interface while we're in FL Studio or any other audio workstation that you can actually load this built plugin into, which I think is cool. And this is hopefully a little nicer than JUCE, which you can only, as far as I'm aware, create the user interface by writing code to like you would in like CSS or JavaScript, place elements within the user interface, which is a little more difficult, in my opinion. So apparently I could do sync parameter tags. With this change. Well, so I'll just edit them up here. I don't know how I associated it with. Oh, there we go. So yeah, I just call it by the name. That name we passed in the controller CPP file, so that's where it is. Because so what I did right now was I synced parameter tags that read this file over here to controller CPP file. Took these names, the parameter tags, kind of similar to what JUCE does with the parameter attachments. And now we've associated that. Now where did it go? I don't know if I can. I just need to know how to save this. So let me. Yeah. Save it there. Okay. Let me see it. It's different again. Let me rebuild the plugin now. Control Shift B. You know what? Let me just clean it. Clean it, build it again. So many tests. Nice. Built again. So let me go back and move that over. Build. So now our user interface should stick with the plugin. Have it close. Let me refresh FL Studio. Make sure it's okay. It's okay. Well, let me get it in here. Is there not? So it does. Nice. So I didn't actually know how to do that before, but we can create things that we can modify. And I believe, yeah, you can create an automation clip with these. My JUCE plugins, you couldn't actually make the automation clips, or I didn't know how to. I'm sure you can make automation clips. But this, it kind of has that feature right out of the box. And again, we set that right here. Can't automate it. So all that stuff pulls together into this UI desk file. And we don't have to do a whole lot to do this. You can save this directly from this editor here. What I don't know though is like when you're shipping one of these products, how would you remove this like from the shipped product? Because you obviously don't want the user to be able to select that. I'm not exactly sure how that works. But that right there is a very quick way to make a VST plugin using Steinberg SDK.